Today's lesson's over section 7.3, which is talking about separable equations. So here, we're mainly going to be focusing on first order differential equations for this section. And that just means the highest derivative is the first derivative. So a separable differential equation is one that you can rewrite into a different form, which kind of sets us up to being a fraction or a proportion. So if I have dy over dx, that's equal to g of x times f of y, so two different functions with two different variables because we have both functions going on at the same time. And so with that going on, if we rewrite so that the f of y is down the denominator, so we kind of change it to h of y, which is the same thing as 1 over that function moved down, so we're kind of changing the power essentially. Once we do that, we can cross multiply and take the integral of both sides. And so that allows us to take the integral of f of y with respect to y, and we can take the integral of g of x with respect to x. And so then we're able to actually find the actual original equation from that. So for example 1, I want to solve the differential equation of dy over dx, which equals 2x cubed divided by sine y minus y. Now here, this one's already set up where the y's are diagonal and the x's are diagonal, so then I can just cross multiply and take the integral of both sides. And so then the antiderivative of each will get me negative cosine of y minus y squared divided by 2, which equals 2x to the fourth divided by 4 plus c. Now notice I can reduce the 2x to the fourth over 4 to x to the fourth divided by 2. Now here, I want to be able to solve for y, but sometimes you're not able to do that because I can't really get the y out of the cosine. And so sometimes you can't solve for y explicitly, so we kind of have to leave our equation as is. And that's okay. So anytime you can't get y or whatever variable you're solving for by itself, then that's okay. Letter B is using that solution, or that solution, to help us find the c value when y of 2, so 2 is our x, and then pi over 2 is our y. And so then from there, I just want to plug in those values, so pi over 2 every time I see a y, plug in 2 when I see an x, and then simplify. And so then that allows me to get the answer for c to be negative pi squared over 8 minus 8. And so then I go back to the original that I had over on letter A, and I plug in my newfound c. And then that would be my answer. Example 2, now sometimes you're going to have to move things around, so notice that the y is not in the denominator, so I have to move it down. So that means the negative, it needs to be moved down by a negative exponent, so I get y to the negative first there. Once I have that set up, now I can cross multiply and take the integral of both sides, and then I can take the antiderivative. So remember, for y to the negative first, the antiderivative will be ln of the absolute value of y, and then x to the fourth divided by 2 plus c is the right side. Now I want to get rid of the ln, so I have to change it to exponential form, which makes it e to the x to the fourth power divided by 2 plus c power. Now also with this, when you have a absolute value of a y, to get rid of it, remember that absolute values are like a v, so you have a positive slope one and a negative slope one. So when I'm solving this, to get rid of the absolute value for y, I need to tack on a plus or minus on the other side of the equation to represent both solutions. Okay. In example 3, here I'm talking about thetas and t. So theta is the one we'll be solving for because it is in the numerator of that derivative. And so here, this one has 4 terms, and so it may not seem like I can get them all separate, but if I group them like a polynomial expression, I can actually factor out a t and a negative 3 out of those two sets. That leaves me with theta plus 2. And then I can move the theta plus 2 down and make it to the negative first, and then I can do my cross multiplication here. And so then here, for theta plus 2, that'll be the ln of theta plus 2, the absolute value of that. And then The other side, t squared divided by 2 minus 3t plus c. And so then changing it to exponential form moves it all up. Changing the plus or minus to get rid of the absolute value sign, and then subtracting 2 gets me my final answer. Okay? All right, have fun.